Hello, we are Group 14, and this video we will explain to you about energy consumption in central metabolic pathways in human body. Introducing our friend, Jeffrey, he is very athletic with ideal body mass index. So this morning, Jeffrey decides to take a hike on a mountain that would take approximately about 5 hours to reach the top. He feels very energetic at this moment because he had quite a breakfast today with sufficient amount of carbohydrate, lipid and protein. 3 hours later, Jeffrey starts to feel tired and hungry. At this point, his body reaches the starvation state. So, the first phase begins, carbohydrate metabolism. This occurs in the bloodstream as the blood glucose level is low, which is detected by the brain, and the brain sends a signal for the pancreas to release the hormone glucagon into the bloodstream, so the body will have normal blood glucose level again. So, how this process actually happens? In the liver, the hormone glucagon is used in the process called glycogenolysis, in which the stored glycogen in the liver would be broken down into glucose precursors, which is glucose 1-phosphate and glucose 6-phosphate with the help of enzymes. As the glycogenolysis continues, glucose is obtained and released in the bloodstream. Hence, the glucose blood level is increased and the glucose can be used next in the glycolysis process. Glycolysis is the process of breaking down the glucose into pyruvate, a 3-carbon molecule. This process involves 10 key steps that can be divided into 2 phases. The first phase involves the first 5 steps is called energy requiring phase, while the other 5 steps in second phase is called energy releasing phase. The first 5 steps will use 2 ATPs to break down glucose into glyceroldehyde 3-phosphate and dehydroxyacetone phosphate. The glyceroldehyde 3-phosphate molecules will then continue to oxidize until it turns to final product, which is pyruvate, and releases 2 ATPs and 2 NADH molecules. The pyruvate molecules produced in the glycolysis are further oxidized into acetyl-CoA to be incorporated into the citric acid cycle. It is a crucial process in metabolic pathway as it generates electrons that can be used to produce ATP in electron transport chain. Overall, carbohydrate metabolism of glycogen during starvation can produce a net total of 31 ATP, so Jeffrey can proceed his journey. After the next 2 hours, he reaches the top. He starts to set a tent and leaves his bag of food behind. Suddenly, a wild bear approaches and it takes the bag with the food away. As it is getting dark, Jeffrey is getting worried as he is left with only water. Plus, he is already starving and getting tired from all the hike. Jeffrey has no choice but to spend the night on the mountain to wait for the next morning. It is getting cold and his carbohydrate metabolism is depleting. To stay energized and warm under the starvation condition, his body is going into the second phase. Lipid metabolism. In the adipose tissue, the enzyme present its hormone-sensitively pace will break down the stored triglycerides into fatty acids and glycerol into the bloodstream. This catabolic reaction is called lipolysis. The inner mitochondrial membrane is impermeable to fatty acids. To pass through the membrane, fatty acid must be first activated by incorporating with coenzyme A molecule and resulting acyl coenzyme A. Activated fatty acids now can be transferred from cytosol to mitochondria via the specialized fatty acid transport called the carnitine shuttle. The acyl coenzyme A will be conjugated to carnitine molecule and become acylcarnitine to be able to pass through the inner mitochondrial membrane. Once it has passed through, the acylcarnitine will be converted back to the activated form, acyl coenzyme A. To obtain acetyl-CoA from the acyl-CoA, it has to go through the process of beta oxidation, which can be broken down into a series of discrete steps: oxidation, hydration, oxidation, and cleavage. Firstly, the fatty acyl-CoA will be oxidized to yield NR-CoA. Second, the NR-CoA is hydrated to yield alcohol. Third, the alcohol is oxidized to a carbonyl, and lastly, the acetyl-CoA is cleaved from the carbonyl molecule. So, As the fatty acids have been already converted into acetyl-CoA molecules, they can proceed into citric acid cycle and electron transport chain to generate ATP. But what about glycerol molecule? Unlike fatty acids, glycerol can directly enter glycolysis and form glucose. This is quite important because without some glucose, there will be not enough oxaloacetate in the citric acid cycle to incorporate with the acetyl-CoA. As if there is not enough oxaloacetate, acetyl-CoA will form into ketone bodies instead that could be used to generate energy, be accumulated in blood, and excreted in urine. Now, Jeffrey has some energy for his body to function and kept warm while he is sleeping. The sun is up. It's the next morning. It's time for Jeffrey to go home. Wonder why is Jeffrey still has some energy even though he has not eaten yet? The third phase, protein metabolism. The muscles contain protein that can be broken down into amino acids. Depends on the side chains. Amino acids can be degraded into many other metabolic intermediate that can be categorized as glucogenic amino acids and ketogenic amino acids. In the liver or in the kidneys, amino acids must first go through the amination process to remove the amino group. Most amino acids can be deaminated directly, but some need to be transformed into keto acid to form glutamate. As an example, glutamate form will proceed to be deaminated into alpha-ketoglutarate. In protein metabolism, many amino acids can be integrated into the citric acid cycle to keep generating ATP in the electron transport chain. Most of the listed amino acids are glucogenic, except for lysine and leucine. Thankful for the central metabolic pathway, even in starvation, Jeffrey still has some energy to go home. Thank you!